8 session series will also be put on to our YouTube channel. You can see that. And as these are learning, right, we suggest you, in fact, to come up with as many questions as you have, right? And we will try to answer all those questions, and which we could not include in the program, we will answer them later on as well, right? So feel absolutely free in raising your questions, right? There is a proper place given for the question, so put your questions there only, and we will take all the questions in the end of it. So let's begin with today's session. I'm putting up my presentation. Is my slide visible? Okay. Yeah. So this is a 8 session series, and today's session is on defining baseline and ideation. In our invitation emails as well as flyer itself, we have given all the 8 topics. We'll see them because in one session you cannot do justice with all of them. So that is the reason why we have distributed it among the 8 different topics. So here are the 8 topics. The first one is defining baseline and ideation. That we are taking it today, that is the Wednesday. But as we had planned earlier, that we will all be having our programs on Tuesday afternoon at 4 o'clock. So all these coming Tuesdays, 8 Tuesdays, we will be having our session. So these are the dates. You can note it them, right, and you can come. The advantage of attending a live session is actually going through all the question answers, right? Others questions, others answers also are coming to you, and you also get an opportunity to raise the question. And if at all you are not able to raise the question, you can put the question to us later on also through email or through WhatsApp. We will be responding to all of them. So we will be having separate sessions on defining baseline and ideation, finalizing projects, financing, procurement, implementation, daily and monthly monitoring and verification of the savings, operation and maintenance of energy saving projects, and finally the summary and key takeaways. So let's begin with the first session. Now, what's the importance of a baseline and ideation? Let's try to understand with this. Expectation from energy efficiency is always the difference between the two numbers. The first number is baseline and the second is the outcome of ideation. Friends, I'm not going to share anything which is there in the textbook. I'm not going to share anything which is there in the so-called knowledge domain of energy efficiency. In fact, whatever we have done here is based on all the actual learnings. We don't claim that whatever we are sharing is the way or the best way to do it. But certainly using this approach, we have definitely achieved a reasonable amount of success in delivering energy efficiency, in carrying out energy performance contract, in working at a whole facility level for the establishments. So that's how this is. So I repeat it again. When we say energy efficiency, everybody will say, how much is the efficiency? 80%, 85%, 90%. And we usually reflect the energy efficiency with a single number. But what is the purpose of energy efficiency? The purpose of energy efficiency is always to get the savings. Now, savings cannot be one number, right? Saving is always a difference of two numbers, right? So that is how I have tried to define it here, the importance of a baseline and ideation. Ideation means what is the energy saving project that you are trying to do, right? But before reaching to a particular project, you are actually ideating it. You are actually trying to arrive at which project is the one which is most suited for you, right? So expectation from energy efficiency is always a difference between the two numbers. The first number is the baseline and the second number is the outcome of your ideation, right? So these are the two things which are going to actually define the purpose of the whole energy efficiency exercise. That's why this is very important. So in today's session, we have these 14 slides, right? So we will see in simplest possible language what is baseline, what is ideation, and why is that we need to consider them together, right? These are totally two different things, right? But why is that we are emphasizing that we must handle them together? Then a thought that is beginning with the end in mind. This is Stephen Covey's first habit of highly effective people, right? So what is the purpose? Why is that baseline is very important? Because you are going to use this baseline to prove the savings. So the whole lot of time has gone. The baseline is already documented. It is there in your contract, right? And at the time of proving that how much is the saving, you are using this baseline. So this is very, very important. So that is why you need to think about baseline with the end in mind, right? And we have found this aspect very, very important. Then we will see 4 approaches of measurement and verification, right? That is as per the IPMVP guideline. We will see them, right? That helps us to decide how we are going to actually quantify the savings in each of the energy saving project. It is very important. Then whenever we go for baseline, so baseline can be whole facility energy consumption, or baseline can be nameplate efficiency of a particular equipment. So there is a whole lot of variety, right, or a whole lot of aspect which is there in a baseline, right? But both of them matter. So we will see here how both of them are completely different, and both of them are absolutely necessary, right? Then we will see ideation for energy cost savings, how one should go about it, or how we have gone about it, right? And basically the old approaches of energy efficiency, right, that is basically carrying out energy audit or preparing a DPR, right? These things have a very, very limited impact, right? We will see that why it is so and how it is so, and how do we handle it, particularly during the energy performance contract. How do we go for financing even without them, right? We are also going to share with you what we didn't do. We are also going to share with you what we did, right? Then after doing all this, both of these exercise, right, there is a separate step, we call it as verification. We have to do that, right? Because the mistakes are possible, right? And that is the reason why verification is absolutely necessary, right? Then we will see that the actual baseline which we have worked on in an actual particular case. Then how we went about the ideation. I mean, how we went about finding different energy saving opportunities, and then how we went about listing them all out, right? So the finalizing the projects is a next phase, right? That we are not doing in this session, right? Because it is the ideation which is very, very important. So that is the reason why we have planned it here, right? Then what have been our key learnings in baselining, right? And what have been our key learning in ideation, and then the summary, and then some of our past experiences. So let's move further. So what is the baseline, right? Now you see on the right hand side, there are 2 graphs, right? One is in a greenish color, another is a bluish color, right? And you see that there is a one line above it, and then there is a one line below it, right? And then on the x-axis you see the months, and on the y-axis you see the energy cost, right? Because finally your energy consumption, right, if the energy consumption is in form of electricity, if it is in form of DG electricity, if it is in form of LPG, if it is in form of HSD, right? But finally, in order to procure all different forms of energy, you are incurring rupees, and your end objective is to reduce these rupees, right? So all the baselines here in this picture are translated in form of rupees, right? And after the project activity also, it is transferred in form of rupees. And then you see a clear difference between the numbers, right? And of course, here you also see the variation in savings, right? It's not exactly following. It's not possible, right? So net sum of all is your overall outcome, right? So you see here that your savings are more in summer months, right? And they are lesser in winter months, right? This may be because of HVAC, right? But there is no sacrosanct such kind of a concept that in every HVAC system you are going to find it like this, right? So every case is completely different. So friends, let's see what is the baseline, right? So baseline is a reference point from where you are going to actually measure the outcomes, right? How much is the saving? You will require the baseline, because it is that baseline where from you are comparing, right? Like for example, someone is having X weight, right? And he feels that he is overweight and he is trying to reduce the weight, right? So his whole exercise refers to that baseline weight, right? And from that he is trying to do all the reduction, right? So it can be in power terms, it can be in energy terms, or it can be in even in kVH terms, right? Because many of the utilities are having kVH billing and not kWh billing. Or it can be rupees equivalent of all the energy cost, or it can be specific energy consumption, or it can be simple efficiency, right? And so on, right? So as many ways you can think of baseline, so many ways baselines are possible, right? But what we have seen over a period of time is keeping it simple always works, because end purpose of any energy efficiency project is, first of all, energy cost reduction. Second, maybe reducing carbon footprint, right? So, but there is no third broad objective. There may be several small objectives like improving reliability of equipment, improving the functionality of the equipment, right? But they are all secondary, right? On that, it's very difficult to quantify the benefits in terms of monetary terms, right? So what we have seen is that in monetary terms, it always works out better to put the baseline, right? If you are working on all the fuels or all the forms of energy, so whatever you are working it, sum them up, right, for a particular month and put that number as a baseline, right? Now, obviously, the tariff of electricity, tariff of diesel, right, tariff of LPG would be changing, right? And this change, nobody is responsible, right? But there is no hard and fast rule, right? If client is comfortable, if ESCO is comfortable, even that is possible, that contracts are happening in a variable rate, right? But it is always better to fix it, right? Because that is not fundamentally in our end, and speculation is not good, right? So these baseline numbers are there from previous consumption, right? I mean, before project activity, what is the consumption for that particular month, multiplied by fixed tariff, right? Be it HSD or be it electricity, and the current consumption into fixed tariff, right? So difference of these two numbers is the gap of these two lines, right? Which you are able to see, right? So this is how it works better, right? And whatever we do, right, it must be agreeable to all the stakeholders. That is very, very important, right? Then ESCOs have not built these baselines, right? Whatever numbers which comes from the client side, that has to be there, right? But then the clients, what I should say, that transparency should be so good that it should be believable to ESCO. So this is absolutely a joint work. It's not that ESCO is delivering the savings, or the equipment which is brought from the OEM is actually delivering the job, right? It's actually absolutely a clean teamwork, right? So unless and until that teamwork is not established, we have seen that it most of the time such kind of contracting doesn't work. But if that kind of a belief and faith is there, right, then why not? It is very much possible, right? And operating hours are never in ESCO's control. That is what has happened in particularly during these COVID times, right? Many of the manufacturing facility as well as commercial buildings were closed, right? So these kind of shutdown are not in any of the ESCO's control, right? So those times, right? How do you quantify savings is has to be absolutely detailed out in your contract, right? And should be monitored, right? And should be honored as well, right? Because in a shared savings contract, it is the ESCO which takes the loan, right, from the bank, and ESCO has to repay the loan, be it COVID or be it no COVID, right? So these kind of expenditure will happen only when the customer shows that kind of a confidence, customer shows that kind of a commitment from their side that yes, ESCO's investments and ESCO's efforts would be paid in terms of the contract that has been signed. So let's move further. So this is what the baseline is. Now, what is ideation, right? So ideation, there is no one fit solution for all, right? Even in same kind of commercial buildings, our projects have been quite different, right? Over a period of time, new technologies also come in, so that also makes the project quite different, right? And we need to consider it's an approach like a doctor, right? Wherein doctor has to examine every patient and find out what is wrong, what is the diagnosis, and then doctor gives the treatment, right? Even if the disease is same, the doctor's exact prescription is quite different, right? So that is very important. And it is the baseline, right? Numbers, right? those are going to actually give you a lead for the ideation point of view, right? And the ultimate purpose of ideation is to actually impact the baseline, right? If whatever energy saving projects you have done, and if it is in that project, it is giving you very good saving, but in their overall bill or in their overall energy cost, things are not happening. So customers would not be taking ultimate interest, right? So customers are also responsible because they know their production programs, they know their expansion programs, right? So how to make a baseline eligible for the overall project period is their responsibility as well, right? So it's not about technology or it's not about energy efficiency project. It's about basically the diagnosis. It is about basically the baseline number and the post project number that is going to create the difference, right? So that is the key for any ideation of an energy saving project, right? Then what happens is, for example, if you take case of a chiller, right, or if you take case of a furnace, it will always be there with a multiple energy saving project, right? Multiple energy saving project with the same energy consumption number, right? And now every project will have certain potential, but the moment you are implementing one by one project, your actually baseline is reducing, right, and decreasing, and there is no formula or there is no calculation that is possible that you can do it, right? It's only your experience that helps you to improve on this particular aspect, right? So with every energy efficiency technology, you are putting it on a common baseline. You'll have to consider that correction factor for implementing the next project, right? So summation of all different projects is going to be actually lesser than the actual savings that is achieved. So from that point of view, it is very important. And what we have seen is that it is always better to deliver more than the claimed savings. Then and only then energy efficiency projects are respected well. Then, as we have seen, winter and summer savings can be quite different, right? Then, however, we feel that this is this technology, we feel that this is that technology. But at the end of the day, every energy efficiency technology is basically rupee invested versus rupee earned or rupee saved, right? You all will agree with this, right? So fundamentally, energy efficiency is a game of return on investment, right? And that is absolutely true with any other business, right? So I repeat, energy efficiency is fundamentally a business of return on investment, and it is like any other business, because in any other business, the fundamental concept is return on investment only, right? Now, how much of saving one should go for in working out with a particular facility or with a particular project or with a particular contract? What we have seen is that 20% is a good number, right? It has a very strong impact, right? Particularly in engineering industry and in commercial buildings, it is very much possible to achieve this kind of thing, right? In primary industry, it's not possible, right? But I'm talking about mid-size industry. I'm talking about large-size buildings. It is very much possible to achieve this, right? Then, as we said, that it is a ROI activity, right? Whereas most of the time, energy efficiency projects are completely dominated by technical aspects, right? Whereas it is very much possible to actually reduce the energy cost and give the actual benefit to the customer, right? So what we have done is we have developed our competency on 30 energy efficient technologies, and we keep this number same, right? If we have to take a new technology in, we will take out at least one of the technology, because it's impossible to maintain relations with the corresponding OEMs for so many technologies, right? It's very difficult to maintain supply chain for so many number of technologies. So this is what we do, right? And during implementation, we see to it that we choose finally 6 to 8 technologies, not more than that, right? Because end of the day, more technologies becomes more difficult to manage. So you have to optimize everything, right? So let's proceed further, right? So now let me again repeat why we consider them together. That is the baseline and ideation, right? Because it is the ideation that creates the second number, right? The first number comes from the baseline, and it is the ideation which creates the second number. And the whole purpose of overall assignment is to create the difference between these two numbers. So that is the reason we always consider, or we always work on baseline and ideation together, right? And that is why we always say that ideation cannot be done in isolation, right? It has to be done with the thought that whatever projects we are ideating, right, what will be the impact on the baseline energy consumption and overall energy cost. It's the key to overall success, right? Then uh, energy efficiency project or energy efficiency intervention, right, has to make a big impact, right, on the overall energy cost. If we very categorically say that energy efficiency has a role to play to really make facilities or buildings net zero, energy efficiency really have a role to improve the profits, right, of a business organization, right? However, it is very unfortunate that I mean, normally people will say that we do energy efficiency projects every year, right? But what it means that saving potential existed in that facility since years and years, right? So energy efficiency exercise has become unfortunately a sort of a ritual thing wherein every year some of the other things is being done, right? Instead of what should have been done, that let us go for in a big way, right, to implement majority of the energy saving project, because it is absolutely a very good ROI initiative, right? And if everything is done in a very transparent way, right, and if it is proven that the energy efficiency investments are actually delivering result to all the stakeholders, then it is really a very good thing for everybody in the fraternity, right? Everybody in the industry, right? And what is also possible, and this is what and where we are working on at present, is that the monthly savings need to be more than the lease rental or the EMI, right? So we are trying to do this particular aspect, right? Then what happens is the customers are actually getting the net positive cash flow through the energy interventions, right? So let's move next. We have said very clearly that the importance of baseline is so very important that we have to keep the end part, that is the monitoring and verification of the savings in our mind. That is the purpose, that is the reason why baselining is considered, why baseline is agreed, why baseline is defined, right? Okay. Then what happens is, if your baseline belongs to summer, and you are trying to do a project activity in winter, it will not work. Or if it is vice versa, in that case also it is not going to work. So one has to be very, very careful, right? Particularly with HVAC kind of projects. Then whatever is the baseline that is agreed upon, right, has to be there in detail in the contract, right? And it's very difficult and complex process to incorporate climate change, right? You may do simulation, you may do output of simulation, right? But then what happens is every stakeholders is not competent in carrying out that simulation, right? So people have to agree upon the simulation because you are saying it, right? And that's what we have seen, that it doesn't work, right? So practically we have seen is that let's have a very simplistic method for doing things, right? It may have higher level of assumptions, right? But that's fine, because overall agreement of every stakeholder is the key to a successful energy performance contract, right? Then also trying to make any impact of a production level, right, is also very difficult, right, on the specific energy consumption level, right? So baselining is something which is key to energy efficiency project, right? Normally we focus on the technical aspects of energy efficiency project, the adaptability aspect in the existing machinery, right, as a retrofit. So while all those things are important, but if the baselining is done wrong, then there is no way one will be able to ever arrive at how much is the actual energy saved. So that is the importance of baselining, and that is why baseline is the first thing in any energy efficiency project, right? Then with the help of ISO 50000, there are many units which have gone for. They maintain the data very, very well, right? And the same data actually becomes quite reliable to be used, right, in energy saving project, right? And the usage level, right, again the same thing, right, is not in ASCO's control, right? For example, occupancy, for example, production level, right? So then quantifying back that what would have been the impact of production level, if the production level would have been of this, right, then the moment we go to the would have been kind of a language, the acceptance from different stakeholders actually reduces. So that is the reason we strongly suggest that keep the baseline as simple as possible, even if it is not accurate, right? But it is agreeable to everybody, right? we do final decision making based on qualitative thinking and not based on quantitative thinking, right? So these are very important aspects. Move next, right? So these are fundamentally four approaches, right, to deliver the energy saving project, right? The first one, that is called as A, that is retrofit isolation. So what you are doing is that, for example, if there is a lighting fixture or if there is a motor, so how much is the power it is drawing? And let's, for simplicity, let's assume that it is drawing a fixed power, right? So this much of kilowatt minus this much of kilowatt multiplied by the agreed operating hours. The same thing happens in when the hydraulic setup is converted to servo motors, right? Your earlier kilowatt consumption is high than the later on kilowatt, right? Or if it is a cyclic load, then we can always take it as an average cyclic load, right? Because in case of a servo motor or a hydraulic motor, your load will not be instantaneously constant. It will be constant from a particular cycle point of view. So that's how it can be simplified and it can be done. The second one, you are actually doing all parameter measure, but for that particular project only, or for that particular set of equipments only, right? Like for example, it is a boiler and your complete condensate recovery and steam circulation system, or for example, it is a HVAC system, right? So this is one complete system inside your whole facility, right? And the third one comes the whole facility, wherein every energy consumption number is considered, right, within that particular boundary, right? And the fourth one is the calibrated simulation. So calibrated simulation, for example, if you want to include energy efficiency project in a greenfield project, which is a fresh project, wherein you do not have a baseline. So how do you do it, right? So in that situation, the calibrated simulation, that kind of approach is adopted. So for your baselining, you can opt for any method, any of these four methods, right? But do give consideration in detail what will happen once the project is commissioned, right? What will happen when the savings are actually discussed on a month-on-month basis, right? Get into the ESCO's shoes, get into the client's shoes, get into the banker's shoes, and think from all the point of view, think completely holistically, and then only come up with your own acceptance for the baseline, right? Because it's a contract. Once it is done, it is done. Later on, it becomes very difficult to change that. Let's move further. Now let me explain the macro and micro aspect of visualizing the baseline, right? In your contract, you would either be having macro aspect or you will be having micro aspect, because baseline would be one number. It will not be many numbers. However, when you try to fix the baseline or when you try to accept a baseline, right, at that point of time, you go through several aspects of the facility. You just don't go through that particular number. So let's see here. What is macro? Macro is your annual energy cost, right? Whereas what is micro? Micro is your detailed energy balance, wherein you are also going up to where is the 2% energy going, where is the 3% energy going, and you are trying to understand and find out all that particular equipment, right? You cannot do it with any one of the approach. Both of them are important to understand. Excuse me, let me take water. So whether heating and cooling both are involved or there are only motive loads, right? What is the overall project size? Then what is the number of initiatives involved? This is your corresponding micro aspect. How much is the boiler or furnace efficiency, right? Whereas what is the motor nameplate efficiency, right? So I'm just trying to give you a visual picture of two different aspects, right? So that you get a feel of what is the macro and what is the micro part of it, right? Going by any one is wrong. It creates lots of confusion or later on things, right? Obviously, you are going to impact on the macro part through summation of all the micro part, right? But end of the day, the result has to be there on the macro part, right? Then how much is the overall investment in the energy efficiency project, right? Whereas, what is the investment in energy efficiency operations? Because we have observed in many of our projects, rather most of our projects, we have done operations of energy efficient equipments or whatever retrofit we have done. So we have operated ourselves, right? So when we have operated ourselves, it was an additional cost to us, right? But at the same time, we found that the additional savings are fairly high, right? So these things also matter, right? Then the macro visualization helps us to not to miss on any energy cost, because it is a total picture, right? Whereas the micro one, right, we may turn out or we may reach out to a energy saving proposal which is so insignificant that even if the percentage savings are quite high in that particular project, the its overall impact may be very low, right? So whenever the overall impact is low, right, the interest level from the client fraternity is usually we have seen very small. So let's move further. Now, this is something which is something very different, right? What we have observed or what we have done, right? So whenever we are trying to do ideation, right? So ideation of energy saving project, obviously it is an energy audit report, right? Or a detailed project report, right? We have ourselves been consultant for first 15 years of our profession, and we have ourselves delivered many of the energy audit assignments, maybe over 500, right? But when we started doing energy performance contracting, and then we re-evaluated what is the role of these energy audit reports or DPR, right? So in the beginning we did it, right? But there is a lot of cost component to energy audit report and a detailed project report, right? Which are normally not considered, right, by the client fraternity, right? Because they are looking for actual savings, right? These might be means of it, right? These might be considered as a cost component, but these do not necessarily deliver a positive outcome, right? Let me explain it in further detail, right? Because, for example, preparation of an energy audit report or DPR, right, may not be actually funded by the customer, right? Because their feeling is, right, that this is our present consumption, you have to deliver the output, right? So, and even if it is funded, let's take the another case, right? If it is funded, the doubt still remains whether the savings will happen or whether the savings are not going to happen, right, in an energy saving project. And we have quite invariably we have seen that many of the energy audit reports, rather most of the energy audit reports, I have not seen all the energy saving projects are getting implemented. Whereas it is very ritual in any industry or any facility, some or the other energy saving project gets implemented every year. What does this mean? This simply means that this potential existed since years. We have just done that now, right? So energy audit reports or DPRs takes a lot of time, right? And chances are very high that unfortunately these all things remains a ritual exercise, which is done either every year or every 3 years or every 5 years. We have seen in industry, we have seen in commercial buildings, right? But we haven't seen that all the projects are implemented, right? Then what happens is the field studies or the efforts which are put to carry out or to produce this kind of energy audit or DPR, they are also quite a lot, right? And they consume a lot of time, and they also delay the overall outcome of the assignment, right? So that's why we started thinking that there has to be some other way of doing it, right? So then we have started doing it project by project, right? So to work it out for a particular project, it's comparatively an easier exercise, right? Based on our experience, we can always say that overall savings, right, we will be able to deliver this much percentage, right? But obviously, this much of percentage will not be coming out from one particular project. This will be a net sum of all the projects implemented, right? So every project, this will be the baseline. Every project, this will be the component of the project, and this is the outcome that is expected from this particular project, right? Then next project, then next project, and then next project. So we have found that the customer side is also very comfortable with it, right? Because going one by one is a good way of doing things, right? So let's proceed further, right? Now, so I just shared with you all that what we didn't do, right? But now let me share what did we do, right? So we have always given more importance to diagnosis than the energy efficient technologies, right? Like what is the current level of energy cost, right? And any energy intervention or any ideation is going to impact the baseline in what manner, right? That is how our thought process begins with, right? And believe me, friends, there is no dearth of energy cost saving technologies. They are as high as number of medicines available in a pharmacy shop. But as the doctor examines you, finds out what is wrong with you, does the diagnosis, and gives you 4, 5, 6 medicines, that's it, not more than that, right? And that is sufficient for us to get to our required level of health, and to get rid of the ailment, whatever you are having. So we have found that this kind of approach works pretty well, right? And we have also started sharing energy efficiency project right at the walkthrough level, right? Because end of the day, the identified project or identified areas of savings, right, would not be changing it, right? It may not have detail, right, but it helps. So customers also get confidence that yes, this is how the overall approach is, right? Um, then we also share ample of case studies, right, to give a support, right, not just the calculations, because end of the day, these calculations are done by us, right? Calculations are done by auditors, right? Uh, and even if the method of calculation is right, but the customer's confidence doesn't come on that, right? But if there is a case study transparently shared with the customer, uh, that kind of impact is phenomenally high, right? So we do that, right? And with every ideation, we start correcting the baseline, right? Because that particular number of consumption is actually reduced because you have already done one particular project, right? Then we give more importance to actual results than calculations, because we do have our own experience of 10 to 12 years of actual implementing energy saving project through energy performance contract. So even if it is our own calculation, right? So calculation may say that this much will be the savings, but actually we have seen that the savings have been less, savings have been more, right? So that input we have given much more importance than the actual calculations, right? At the end of the day, the best thing for energy efficiency world is, let us come up with a cash flow wherein the annual savings are always significantly higher than the EMI or the lease rental, right? So that's the whole philosophy of coming up with an energy saving project, right? And also always maintain a full transparency, right? Say sharing actual results in the Excel, right? All the calculations also in the Excel, right? And then at the most using PPT instead of going for a detailed word report, right? Because that we have seen that it only takes your time, right, for you to write it, and take time for the client to read it and understand it as well. So let's move further. So what we do at this stage, when we have already done the baseline and we have done the ideation, right? Then we completely do a verification of everything, right? And why we do it? Because this is our quality control step, right? And we have seen that it works, right? And in manufacturing facility, it is anyway, it is there, right? Whatever is the product which is produced, whether it is meeting all the quality requirement or not, there may be different methods of verification, but there is at least some or the other verification step is in place. So we have done this as a process, and we have seen that this works beautifully, right? Then what we have done is taking inputs from all the stakeholders, right, before finalizing, be it OEM, be it state regulations, right, and the customer themselves, right? It is important, right? One may agree or one may not agree with any of the input, but we have often seen that taking this feedback at this level itself, right, helps actually a lot, right? Then obviously there has been a good number of energy efficiency projects which have failed in different industries, right? And they have not produced results, and that is the reason why there is so much of worry on energy efficiency investments, right? And that is the reason having your learning from the failed project is very important than actually successful energy efficiency project. It's the failed project which gives you lots of lessons, right? And there is nothing wrong in sharing this, right? I think no need to actually feel shy about it, right? Nobody's work is perfect in this world, right? Then at times we take trial implementation, right? And that we have seen that it helps a lot in terms of building customers' confidence, right, as a process, right? Then again, I will repeat, calculation helps in ideation, but insight and experience works better. So we finally we do calculations. It's not that we don't do that, right? But our final emphasis is on the insights and experience which we have gained over the years. So let's move further. So friends, here is the actual case, right? Because unless and until we discuss on the actual data, how things have gone through, one may not get a feel of it, right? So there is electricity and then there is a diesel, right? So these two fuels are there, right? Because DG set will be consuming how much of diesel is completely dependent on the time for which electricity is not there. So we have taken that much of electricity in the grid part itself, right? So you have to take that part in the electricity, and then you have to take the average accepted tariff, right, for all, right? So that has been taken. So that has created your rupees baseline, right? Because you can convert every number into rupees, right? And then so baseline energy cost, how it is there. It is baseline HVAC consumption, right? It's not on the full facility. It is actually on the HVAC side, right? And but for that, it is also very important that this kind of HVAC consumption data is there with the customer, right? And your all condenser pumps, condenser fan, your cooling tower fan, your chilled water, right? Every circuit should be on the same electricity meter, or that complete is totally measured in a particular sets of meters, right? It's not that some of the loads are not in the meter and some of the loads are there in the meter. So there is no baseline that can be done through that method. So it plays that bigger role, right? Then same way your diesel consumption plus the fixed diesel rate, because the tariff can actually change and it is not in the hands of the customer, as well as it is not in the hands of the ESCO, right? Then the same way after doing the project cost. So these are the 2 years of data, right? After the project is implemented, right? So the orange color is the first year, right? And the blue color is the second year, right? There's slight variation in the savings, but more or less it is same, right? So it is very important that the savings are delivered month on month. And that is the precise reason the manpower which we have kept at the site that helped us to actually deliver the savings month on month. So let's move next, because you have to actually calculate the savings also, right? So there are basically 3 projects. So this is the first project, right? So how much is the baseline consumption? That is your first row in terms of tariff, as well as in terms of energy consumed, right? So you multiply that, so you get the baseline in rupees, right? This is for one particular month, right? And then the same way after the project activity. So after the project activity, where is the source of the data, right? So that there is a monthly or daily energy consumption monitoring report, right? So it is taken from that, whereas the baseline is there in your contract itself, right? So serial number 1 minus serial number 2, right, is actually giving you the savings. So that is 4.04 lakhs in this particular month, right? Then let's see the second case, right, which is the diesel cost, right? Because here we completely stopped the boiler, right? And then we went for other means of the project. My objective of this particular session is to have your focus more on the baselining and ideation as a process than on the actual project. We will discuss in the next case about the actual project also, how from the ideation we are actually reaching to the actual projects, right? But here, let's focus on the calculation methods. Let's focus on the ideation as a process. Let's focus on the transparency of the savings calculations. So basically, since it's a diesel and later on it is electrical, right? Because you are converting it from diesel to electrical in this particular case, right? Heat pump gives you a very good COP advantage, right? And then there are lots of other more efficient electrical projects, and you are saving a lot because your condensate recovery is inadequate, your line losses are quite high, right? So like this, it helps. But then what happens is your boiler feed water pump is also getting stopped, right? Your blower is also getting stopped, right? So you have to fix this kind of consumption ex ante. You can't go for calculating, you can't go for measurement everywhere. It is impossible, right? So what has been done, because this is a very, very small component of everything, you calculate all these things in the beginning itself, and you fix them ex ante, right? This is a particular word which was very popular in CDM calculations, right? So finally, you convert both of the previous situation and after situation into rupees, right? and that's how you get these savings, right? 17.10 lakhs, right? And then there is a third project, right? So same way, the savings are calculated, but it has to be done in a very transparent way, right? So the third calculation is actually a subtraction, because your energy saving project will also consume some energy, right? So A plus B minus C is your actual energy cost savings, right? Because there is something which is going on before, and then you are retrofitting it with something else. So retrofit case, and there will be some energy cost. So that is C. So A plus B minus C is your actual savings. So actual in that particular month, the savings which has been delivered by this project is 14.34 lakhs, right? And all these calculation methods are pre-agreed in the energy saving contract itself, right? Now let me share, friends, how was the ideation process, right? Okay, so though here it may look like that I'm talking about a project, but my full emphasis is on the process, right? So for diesel baseline is a number, right? It's a cost, right? And it is getting consumed in the boiler, right? So what we decided that we have to stop the boiler, because what happens is, even if you run the boiler on no load, right, it will keep on consuming diesel, right? You put the boiler on zero load, right? There is no consumption at all, right? But your all the steam lines are charged, right? You'll find that your overall consumption in this situation is also as high as 10% to 25% of your load consumption, right? So this 10 to 25% becomes your energy cost, which is consumed by the distribution side, right? So and there are no calculation methods to do it correctly, right? Believe me, friends, I myself have all the qualifications, right? And never these kind of calculations have gone right in terms of actually getting those numbers, right? It is actually better to run the boiler without load, right? It will keep on consuming some cost, but we will come to know that how much is the fixed loss, right? Then actual load keeps on varying 24 hours, whereas your utility, that is a boiler that runs continuous, right? Then of course your pressure will be reached, and then it will be switched off, right? We feel that it is switched off, so there are no losses, but your line is continuously producing losses, right? Then there was a big modification in the laundry side, right? Because laundry was using hot water as well as steam, right? So that was done, right? Then a water-based heat pump, right, was used, right, for producing hot water, which also gave additional savings on the chiller, right? Because your chiller started working at the partial load, right? It's not that just your some of the load got distributed to the heat pump, so your corresponding load is reduced on the chiller side. But when you actually see the chiller performance, right, you will find that the chiller will give you much better performance at part load than at full load, right? So your very detailed understanding of each of the equipment performance characteristics is also very much important, right? Then the lighting is anyway the simplest of the project. But what happens is, whenever you do lighting project in a air conditioning domain, right, then how do you quantify these lighting savings in the air conditioning side because of the heat load reduction? That plays a very key role, right? And we have seen that this is also a very significant component of it, right? Then on chiller side, right, we focused first of all on the cooling tower performance, right? We implemented some project, and we also found that the cooling tower performance is significantly improved, right? However, later on we found that still there is a scope for improving, right, based on the ambient conditions, right? We are still not getting the best of the performance from the cooling tower, and there is nothing which can be done further to improve the cooling tower performance, right? So we went for an additional cooling tower, CTI approved cooling tower, right, to get best of the results, right? And we got that, right? But this doesn't mean that in every chiller we have to go for additional cooling tower, right? So that is where we say very strongly that it is not that one successful project is Control C, Control V for the other location. No, it is never. Every project has to be detailed out, right? Has to be understood, right? And then accordingly the ideation should be done, right? Then, so like this, we move further, right? These are our several projects which have been implemented, and actually results are achieved, right? I'm moving a bit faster, right, so that I can give more time to your question answers, right? So these are the key learnings, right? At the baseline, I've spoken about them in the main presentation, right? And these are the key learnings in the ideation, right? Never go with the fixed mindset to implement one success story at another location. Always look every case as a separate case, right? You may reach to that situation, that is fine, right? But let us never psychosign, and let us never be tied in terms of ideation process. Ideation is a process, right? And this is the process. You have to do cost analysis, you have to do opportunity evaluation, and you have to do system optimization. And end of the day, you have, from every exercise, you have to transfer the savings, right? This is the key, right? So fourth block is an actual outcome of first three blocks, right? So these are several projects, several great ideas, but end of the day, every idea is finally delivering more savings than the EMI, right? That particular project demands for, right? Evaporative condenser based approach is a very good technology, right? And it is also possible to deliver it under this model, right? Then the chiller optimization. So there is no end to the project, right? Again, this is a set of several projects, right, which is possible in different industries, right? Manufacturing industries, be it MSME or be it large industry, right? Energy saving works equally for all. So friends, this is what I have from my side. Now I will focus on the question answers. Yeah, questions please. So Kunal will be sharing all the questions which have been raised. Hello. Yeah, Kunal, please go ahead.
Yeah. So the first question is like how change in production mix can be accommodated in the baseline, and so that is the first question.
Sure, sure. A very important question. What happens is, what is the change in the production mix that is going to happen is even not known to the customer side, right? Because it is something which is going to happen in future, right? But how you are going to handle it in your contract, that is very important, right? And believe me, it's very difficult to handle this particular aspect. So that is why we have to take care in the baseline itself, right? That if the production mix happens, then we have to move from the option C to option B, or option B to option A, right? Those four methods which we have seen, right? Because that method is not going to work now, right? Because for the projected product mix, right, nobody knows that what would have been the baseline energy consumption, right? So it is always better to actually change the method of saving calculations, right? And that has to be written very crystal clear in the contract itself. Yeah. Next question, please.
So the next question is like we have four IPMV options for M&V. So which is most preferred in the industry, which a customer wants to go ahead with?
See, obviously, customer always wants that the energy cost should be reduced, right? Whatever is the monthly energy bill which everybody is paying, that should be reduced, right? But it can't be reduced just like that, right? That also customers are quite aware of, right? So step by step, several projects are there that has to be taken up, right, in order to reduce the energy cost. So what we have seen is that the first method, right, because operating hours are also not known, right, and that is not in the control of any energy service company, right. So it is always better to work on the basis of kilowatt before, kilowatt minus, right, and also assume a accepted number of operating hours, right, based on past operation, that this is the operation and this is how the things will be considered, right. And the responsibility with the ESCO should be that what is that KW2, right, should be, right. That is what the ESCO is responsible for, right? Okay, not the operating hours. So KWH1 minus KWH2 is not in the control of ESCO because of the operating hours, right? So if we are really looking for a baseline which is equally agreeable to every stakeholder, so in that particular situation, it is basically KW1 minus KW2, because that is actually the power saving which has come because of the technological intervention. So I strongly recommend to opt for that. Yes.
Yeah, thank you. So the next question is, can you detail on calibrated simulation, how it is executed?
Actually, there is a modeling that is called as, like, for example, there is a architectural drawing that is made, right? Its 3D drawing is also made, right? And then what is the type of roofing you are going for, right? Are you going to incorporate any kind of a reflective coating on that? I'm just taking one example. So the moment you put that reflective coating, that software actually accounts for that you have done that. So your heat gain actually reduces, right? So what you're trying to do is that there is nothing in real, right? You have made the drawing, so that is your baseline, right? So you calculate the baseline energy consumption without doing any energy saving project on the drawing itself, right? This is the equipment, this is going to operate for these many hours, this is the heat load, everything is there, right? Then calibrated simulation means you are trying to calibrate it on the drawing, right? And on this drawing, you are actually going to put the measures, right? Actual projects, right? Like, for example, you are going to put the insulation coating, right? You are going to put the daylighting aspect, right? So you are actually trying to calculate that how much is the additional heat gain and how much is the energy saving because of the light. So on the software, everything is happening. So that is called as calibrated simulation. And it helps to take the decision whether to implement a particular technology or whether not to implement a particular technology from the customer point of view. Yeah. Any more questions?
No, we have this much of questions only.
Okay. So, great, friends. This is what we are going to do every Tuesday. This was yesterday. I was actually traveling. I could not plan it. That was a pre-committed date, right? So allow me to make that kind of a slight change, right? Sometimes it happens, but every Tuesday from 4 o'clock to 5 o'clock is what we are going to have our session. And any question that you have, you can always share that in advance to us. Thank you. Thank you all.
Yeah. One more thing I would like to tell, that here onwards, like, there will be only one registration, and that will be valid for all the future programs. I mean, you will get the invitation for the upcoming program that is on 12th, and the same will be continued for the next 7 programs, total 7 programs, because this is the first in the series that we have done today. And for the rest of the 7, there will be just a single registration. So you need not worry about registrations every time. So see you all on 12th, and please share your feedback so that we can again take up the issues that you are actually facing, and make this program more useful for all of us. Thank you.
Great. Bye, everyone. Bye-bye.